Hey class, we're back again, and now we're going to look at example 2 from chapter 8.6. So this deals with solving a surface area problem. This is being done last period on the Thursday, so if there is an announcement, I'm just going to work through it, and I apologize for any interruptions. So the Great Pyramid of Giza in Egypt was built on a square base with the dimensions as shown. You can see the diagram to the right. An artist who works with plate glass wants to build a replica of the pyramid for an installation in an art gallery. The artist is restricted by the floor dimensions, which are 6 meters by 6 meters, and the ceiling height of 3.5 meters. As well, the glass sculpture must have room for a 1.0 meter walkway around its base. The first question we want to answer is what scale factor might the artist use to build a sculpture? And the second thing we need to understand is how much glass is actually required if it can be built. So you can kind of see the diagrams we have down here. We're trying to take this as our actual real-life model, and we're trying to scale it down to fit within these dimensions. So the first thing is what scale factor might be used. Well, I'm just going to pick two measurements that would kind of match up here. So I'm going to look at the fact that this 230.4 meters has to match up with the idea of this 4 meters. So I'm going to go ahead and try and determine my scale factor K. And so in doing that, I'm going to set up K is equal to, and I'm going to take my 230.4 and divide that through by 4.0. And if I do that in my calculator, I think I just get just under 60. So if I do, here we go, we've got 230.4, dividing that by 4.0, and I get 57.6. So 57.6 is kind of that would be the ideal scale factor, I guess, or that is the actual scale factor existing between these two things. But I can make that scale factor easier to use. The one thing I want to be careful of is I want to make sure that I make my model smaller, because if I make it bigger, I'm not going to have room. So currently we're looking at a reduction. We're trying to honestly reduce by a factor of 1 over 57.6. And that's pretty hard to work with. So what I would suggest instead is let's just make that approximately a scale factor or reduction factor of 1 over 60. And so this is actually the reduction factor we're going to use. So our scale factor for reduction is going to be 1/60th. So now that we know that, we want to figure out how much glass the artist will need to build his sculpture. So hopefully you're recognizing that what we're talking about here is surfaces, and so what we really care about is the surface area. Now, if you watched the last video, you recognize that the surface area is going to be affected when the original dimensions are affected by a scale factor of K. The surface area is going to be affected by a scale factor of K squared. So really, what we're talking about is the amount of glass required is based on the new surface area of the scaled down model. And so that's going to come from K squared times the surface area of the old model, or the original model. So I need to be able to figure out the surface area of this actual pyramid. Now, they didn't make this clear in the question, but there's a difference between surface area and lateral area. We're going to assume for this particular question that they are actually including the base as a surface that he needs to fill with glass. So we're going to have, instead of K, we've got 1/60th, and that's going to be 1/60th squared. And now we need to figure out what would the surface area of this be. Well, if you think back to your surface area formulas, we have 4 triangular faces, and so that's going to be 4 times, and each of those triangular faces are going to come from 1/2 their base, which in this case is 230.4, multiplied by the slant height. Now the slant height in this case is 186.4. Oh, sorry, I missed my 6. 186.4. So that's taking care of my 4 faces. I now also have the base, and so the base of this, we're saying it's square based, and that would be 230.4 squared, so plus 230.4 all squared. I think that's actually a round bracket followed by a square bracket. And so this kind of big ugly formula is going to do all the work for us. So I'm just going to take a second and put that in my calculator, taking my time to put it in correctly. So I've got 1 divided by 60. I'm going to make sure that gets squared. And then I'm going to open up another bracket. And I'm going to do 4 multiplied by, and I'm going to open a bracket, do 0.5 times 230.4 times 186.4. I'm closing that bracket. And then I'm adding to that 230.4. I'm squaring that, and I'm closing my both sets of brackets. And I hit a little syntax there in there, so I think I have one too many brackets. And so what I got back was scaled down. I'm going to need 38.60, and I think our measurements here are meters, so it would be meters squared of glass. So again, the big thing I want you to recognize is that you can use corresponding measurements to figure out your scale factor, and that the surface area, if you can find the surface area of the original shape, it's just going to be a factor of k squared that scales that down for you to the new shape that you want to build.